Hello again, and welcome back to another FMOD and Unity tutorial. Finally, it's been a while since we've done one of these, but yeah, hopefully we can get back into some more of these and get the ball rolling again. I just want to quickly apologise for the lack of videos I've been doing. It's just because, I've been busy recently and haven't been able to put the time into them. But yeah, hopefully we can look at some different ideas, get some more out there. What we're going to be looking at today is adding audio engines, or a very simple way of adding audio engines, engine sounds to vehicles through FMOD into Unity. So thank you very much to a Valor Wins for the suggestion. Hopefully this helps you out. As you can see, I have got a lovely jubbly vehicle here, which I've imported through the Unity. So it comes as one of the asset packs you can. Not that. Here we go. One of the asset packs you can import. So if you just go to assets, import package, vehicles, you can drag it out from a file and bring it into your game scene. The reason why we're going to be using this is because, well, hopefully you lot have access to it. So makes it a bit easier. So we're all working on the same level. But also vehicles, because that they all use they're quite heavy on the programming. They use a lot of the physics engines. And all this, if you're actually doing this, if you're using vehicles in a game, yours is probably coded completely different to someone else's. But hopefully this allows you to check out what we've done and get a rough idea of how things work. Cool. So let's jump into it. The first thing we're going to do is actually have a look at the car we're using. And before we play any audio, I just want to talk about kind of roughly how some of the programming works on this car, so we can use that to our advantage, because we're going to be doing a lot of parameter modulation and automation, and changing things depending on how the car is moving in game. So I'm pretty sure there's no audio coming through, so let's jump into it. Let's move that out of the way quickly. Right, so we've got some values here. We've got revs, speed, and an XL, which stands for acceleration meter. So the main two we're going to be using is revs and the XL, not really speed so much. I thought we might need that, but it turns out we don't. So revs on the car in Unity ranges from 0 to 1. Those are two value. Well, anything in between 0 and 1, but it ranges from 0 to 1. And it's purely there for audio. And the idea is it simulates, the revs in an engine building up and dropping down when the gears change. So when the car gets to a certain speed, when the revs value reaches 1, it will drop to a lower value in order to simulate a gear change. What we're actually going to be doing is using parameters to measure this value, to change the pitch of our engine sounds, to simulate those sort of gear changes. And as the car accelerates, the revs build up and you get that sort of noise you hear. That's kind of the idea of the rev. So that's going to be quite important for us. The XL meter is also quite important as well. Basically, the only two, well, again, it ranges from 0 to 1. This changes from 0 to 1 whenever I press W, and that's basically telling the car to move. So the reason why we've got that is because when we're moving and we take our finger off the W key, we're no longer accelerating. The car is now decelerating. Is that the word? Decelerating. Yeah, that's right. Decelerating. So we've got audio files, as you can see down here, for deacceleration. So we want to know when the car is doing that, so we can tell these to play as opposed to our acceleration audio files. So let's just quickly move the car around. I'll just quickly drive it a bit. I'll set these little. Let's move these out of the way. I've set these little blue cubes up to give you a sense of movement, a sense of speed. As you can see here, as the revs value increases, it gets to 1, or as close to 1 as it can. It will drop down a bit. Wait for it. There we go. It'll drop down a bit to simulate a gear change. And as you can see, because I'm holding W, our acceleration value is 1. If I let go of W, that'll drop to 0, and the revs and the speed will drop. Cool. So those are basically what we're going to be using to calculate all our audio. Hopefully, if you're using a different vehicle, you've got similar sort of variables that you can measure. I imagine either if you can't use your revs or acceleration, there should be a speed variable that you can at least use to monitor how fast the car is going and simulate, the sound of the engine increasing in pitch with that, but it all depends. Cool. So, as I said earlier, or kind of hinted at earlier, or implied, whatever word. We're going to be using the audio files that come with the car in Unity, and I've actually imported them into FMOD. Oh, not that. There we go. I've imported them into FMOD. I'm going to be, basically recreating the implementation process with FMOD. Cool. So let's quickly have a look at what I've got here. Let's delete that. Actually, I meant to get rid of this earlier. So this is the event I've actually used in the in the Unity session. I'm going to quickly create a new one so we can go through all the steps again. But let's have a look at how this works. So if I quickly play it for you. So that's what the car's going to sound like when nothing's moving, okay? Our RPM is 0, our acceleration input is 0, nothing's going on. If I change the acceleration input to 1, so I press the W key and I slowly build up the RPM as we play it, this is the kind of effect we want to get. There you go. As you can hear, I was trying to sort of simulate a gear change, but yeah. So the idea is as the RPM increases, we're then fading into other audio tracks that's, have the engine, that are the samples of an engine playing at a faster speed, but we're also changing the pitch so they fade in together quite nicely. And the same thing happens for the deacceleration. So the acceleration input parameter basically decides which track out of these two is going to be played. And again, it's measuring our acceleration meter that we had in game. If I put that all the way to 0 and play you the audio again. There we go, that's what we hear. So that's kind of what we want to, simulate again. So, let's create our own little event. Let's create a new one. It doesn't really need a name. And we'll go through all the steps to see what we did. First thing we want to do is throw some audio in here. So I've got my acceleration high audio track, acceleration low. Oh, hold on. I've already made the first critical mistake. Get rid of these. As opposed to using the timeline to play our audio files, which is what we've done on basically most of our videos so far, we're actually going to be creating a parameter first and adding the audio files to the parameter instead. So I'm going to quickly call it RPM. We'll leave the values between 0 and 1. And I'm actually going to drag the audio files onto here. So put acceleration high there, acceleration low there. And the reason why we're doing this is because we want the audio files to be played and triggered and changed depending on the RPM as opposed to a time value. We don't want the low engine sound to change to the high engine sound after say 5 or 10 seconds. We want it to change when the player increases the RPM. So let's quickly have a listen to those sounds individually. This is the acceleration low sound. And this is the acceleration high sound. Oh, there you go. There you go. And notice how when the parameter value cursor moved onto them, they played. Okay, so that's how they're triggered. Cool. So what I'm going to do is stretch these out so they cover all of the whole range of my parameter. I'm going to put the acceleration high to about 0.2-ish. And acceleration low is going to reach to 0.4, 0.4.5. 0.4.5, 0.45. There you go. I'm also going to loop the individual tracks. So if you click on an audio track and you come down here, there's your loop button. Just press that. So now whenever the RPM value lands on one of these tracks, it will loop until the RPM value moves away from it. Okay. So we can do this for both of them. Cool. And as you can see, we've also created a crossfade here. The idea is when the RPM value... Oh, that's got a bit stuck. Let's just quickly fix that. When the RPM value increases, the acceleration low audio file will fade out and the acceleration high value will fade in, and vice versa when we drop... Well, when we drop it, we won't be using these two, but yeah, you get the idea. Cool. So let's quickly have a listen to how that sounds. Cool, so not too bad, but we want to change the pitch of these because, that doesn't sound too believable. So one way we could do that is obviously modulate the pitch, but we've actually got a secret little weapon we can use, which is auto pitch. And we get this option whenever we add audio to a parameter as opposed to a timeline. Basically, what it does is it modulates the pitch for you depending on the value of your parameter, which is really nice and helpful in this case. So let's talk about auto pitch a little bit. Actually, before we do, I would like to quickly recommend you guys check out the FMOD video about audio engines, or about engines in audio in FMOD on the FMOD channel. Because they go into all of this into a lot more detail, and they use a lot more audio files, which I actually recommend you doing, because it just, it adds more detail, adds a lot more believability to it. Yeah, have a look at that. I'll put a link in the description. Check that out. The only difference is that they use that for the Unreal Engine. So here we're using it for, Unity. Cool. And actually, the auto pitch they have is in a lower version of FMOD, where I think they've only got one of these values that they can change, whereas we have two. So I'm going to talk about these in a bit more detail too. So let's start with the root pitch. So basically, this determines the position of where the original pitch of our audio file is going to be. Okay. If I quickly just turn this off and play you the first audio file, the acceleration low, that's the root pitch, what you can hear there. If I quickly then quickly just slap that on and play it again. Oh, let's add that up a bit. As you can hear, the pitch has dropped. So what root pitch does is takes that original pitch that we heard and places it somewhere on the timeline. Okay? And as you can see, the values range from 0 to 1. And that's because our, not timeline, our range of values on our parameter ranges from 0 to 1. Okay? So I'll read that and say, okay, where do you want to place the original pitch? So if I were to leave it at 0.5, then we would hear the original pitch of this audio track whenever we hit 0.5, and anything below that will be lower. Now, even though this audio track doesn't completely fill up the whole entire range of our parameter, we will still only would hear the original pitch if we were to hit 0.5 and the audio track, was over 0.5. Because it's not, we'll only hear lower pitches, if that makes sense. So to change that, if we did want to hear the original pitch in our case, we'd have to make the value between 0 and 0.45 in this case. I might want to put it at there 0.33, and then when we hit 0.33, we'd hear that value. Okay, so that's root pitch. Sets where you want the original pitch to be. Minimum pitch basically determines how much you want the minimum pitch to drop by. Okay, so this is always going to change. This is always going to change the lowest value. So whenever the parameter is on 0, basically is what our minimum pitch is going to be. Okay. To demonstrate this, let's quickly just get rid of. We'll get rid of acceleration high. Stretch this out. We'll put the RPM on. Oh, hold on. Let's quickly fix that. There we go. Put the RPM on 0.5. Do the same with the root pitch 0.5. Here we go. So whenever I hit play, there's our root pitch on 0.5. Cool. So when minimum pitch is on 1, basically when our parameter is on 0, the value of our parameter or the pitch will not change. It's on 1, okay? But if we were to drop that, this would obviously affect the minimum pitch. If I was to drop this to 0.5, that would basically half the pitch or half the frequency the pitch is playing at. So say, for example, this acceleration low audio file was playing at a frequency of 1000 hertz. If the parameter was to drop to 0, I don't know why this keeps doing that. If it was to drop to 0, then we would hear 500 hertz, which is half of 1000. Similarly, if we were using musical notes, this change would be a whole octave. If you half a frequency, you're basically dropping it by an octave, okay? If we were to do the same, but drop it to 0.25, so it's now a quarter of the original value, if we were to drop the RPM down to 0 now, it would be 2 octaves down, or it would be a quarter of the original pitch. So again, if we were using 1000 hertz, we'd now be hearing 250 hertz when at 0. Okay? Cool. So what happens if I were to then set the root pitch at 0.25? Okay? Well, our root pitch is now at 0.25. So if we were again using 1000, oh, not that. If our audio file was at 1000 hertz, that's where we would hear it at 1000 hertz at 0.25. Again, because our minimum pitch is at 0.25, that would drop it by a quarter. So if we moved our RPM knob to 0, we would then hear 250 hertz. But anything above that will be scaled accordingly. So if we were to put RPM back onto 0.5, we would now be hearing it. We'd now be hearing the frequency multiplied by 4, in the same way that we basically divided the frequency by 4 when we dropped it by 0.25. So at 0.5, we'd be hearing a frequency of 2000 hertz. Okay, and so on and so forth. So basically, any pitch above the root is scaled according to the minimum pitch value, if that makes sense. Cool. So hopefully that made sense as always. I always feel like I ramble when I explain things, but yeah, that's the idea. It's a way of calculating pitch, and it obviously calculates it depending on the root, where the position of the root pitch and the value of the minimum pitch. You can look into that in a lot of detail if you want, and precisely work out where your pitches are going to be. But you can get away with sort of just messing around with scales and trying to find where it blends quite nicely together. Let's grab our acceleration high audio track. I'll chuck that back in. I'm just going to stretch it out again. There we go. Add the crossfade back in, which does automatically. And I'm just going to quickly add the auto pitch for the acceleration high track as well. We'll leave it like that and see how it sounds. I'm not going to tweak it and try and find it, the best way to add the auto pitch. That's what I've sort of done here. Well, roughly on the car engine. Let's just have a listen to how that sounds now with the modulation. Oh, hold on. Silly me, I haven't looped it. Easy fix though, come over here, loop. Right, let's do that again and hopefully not make that same mistake. So yeah, there we go. We've now automated the pitch. If you like, you can do it the old-fashioned way by coming down to here, add modulation, or add automation rather, not modulation, and just plotting in your points on the graph. You get a bit more, precise there. But I feel like with auto pitch, it helps you blend things a lot better. But yeah, because you're obviously affecting the pitch of each individual track, whereas with automation, you're affecting the pitch of the whole track rather than the individual regions. Rather, with auto pitch, you can affect the individual regions. Cool. So that's that. What we're now going to do is add another audio track, and this is where our deceleration audio files are going to drop into. So let's drag them here. Let's add the high there, add the low there, and I'm actually going to add acceleration low into this as well. The reason why I'm doing that is because when our RPM is at 0, we don't want to hear this acceleration low value, because then as soon as we hit W and start to move the car, it will jump quite uncomfortably to the acceleration low and acceleration high track. We basically, when the car's not moving, we're not pressing W, we want to hear this file, this acceleration low, because that's the engine, just sitting still and not doing anything, if that makes sense. So I'm going to add these and just roughly blend them in together. Like that. Again, this doesn't have to be precise. I've already set it up. And you can tweak these however you want. It's just, obviously, you'll be using different audio files, so it just depends. You obviously want to find, what works best for you, what sounds the best. So I'm just going to quickly loop them all, and we'll just, without changing them too much, we'll just add some random values. This is going to sound horrible because I'm not really checking how they sound, but I'm just going to add some random auto pitch values for that. There we go. Oh, dog snoring behind me. There we go. Let's have a listen to that, how that sounds. Let's quickly mute the first track and chuck the RPM up to 1. There we go. Cool. So that's kind of how it sounds as it deaccelerates. One final thing we need to add is another parameter, and that's the acceleration input, as we mentioned earlier. Got to spell it right. I'll just call it Excel for now. Again, 0 to 1. The reason why these are all 0 to 1 is because, as I showed earlier, our values in Unity are 0 to 1, so it just makes things easier when converting them in the programming. So what we could do is just add some volume automation. So when the acceleration is at 0, we're not pressing any buttons, basically. We're not pressing W. We're not telling the car to move. So we don't want to hear it accelerating. Oh, didn't mean to do that. So we'll just quickly drag this down to 0. But when it is at 1, we do want to hear it accelerating. Which, by the way, obviously, if I go back to RPM, this track is for accelerating. I should have named them, really. I'll quickly do that now. So this track is for accelerating, and this one is for decelerating. So when we add volume to this, we want to hear it when it's accelerating, and this is at 1. The same for deaccelerating. If we go to automation, drop the volume, or rather have it up at 0, and when it's at 1, we want it down, because we don't want to hear it. Okay? Cool, so let's have a quick listen to that. Let's make sure I haven't left that muted. I have. Quickly turn it off. So, there we go. Let's quickly increase that. Oh, wait, hold on. There we go. There we go. So that's kind of how the car will sound when, you know, it accelerates and deaccelerates accordingly. And I think that's all we need to do on the FMOD side of things. Cool. So let's quickly have a listen to the one I set up earlier. I'm just going to quickly play it because obviously that was kind of, you know, not very smooth and didn't sound great. We'll have a listen to this just to see how our car sounds when it's accelerating and, you know, deaccelerating. One more time. There we go. So it sounds pretty good. So as always, we're going to save that and build it. In fact, let's quickly delete that event because we don't need that anymore. It's just for demonstrating. Save that. There we go. So as I said earlier, you can check out the video on the FMOD channel, and they go into that in a lot more detail, and I highly recommend you do. But yeah, for a basic engine, this is kind of how you would go about setting it up. Cool, so now we've done that, let's jump into Unity and let's actually look at the script we use. So this is the script that comes with the car. This is for, how Unity does things. But we don't need that, so let's get that out of here. And this is the script I've sort of come up with. Let's have a look into that. So it's kind of simple stuff. We've done all of this before. As you can see, we're just using parameter instances, event instances. And I'll probably link a video in the description or on the screen for you at the top right to check out the videos where we've talked about these in a bit more detail. But yeah, as you can see, what I've done is I've set these up to, I've set them on awake, and I've told the audio, I've told the FMOD event to play as soon as the game starts. Obviously, depending on how your car works, you can add this to maybe when a player comes up and interacts with it, then you can tell the audio engine to start. But yep, it's up to you. Also using our special magic line that makes the event, the 3D event, play in Unity. And again, I'll link that on the screen for you to go check out. And what I've done here, as you can see, is I've set our RPM and our accel input parameters to play according to the revs and the accel input that we saw on screen earlier in Unity. And these can be found in the car controls script if you dig through here. And the way we've done this is basically with this public class here I've called car controller, and I've just called it CC. And to get this to work, I've actually had to add this extra namespace up here because we're using a asset from Unity. I just required this extra line, but you probably won't need that if you've created your own car and you've got your own scripts you've used. As you can see on the void awake function, I've just told it to get the component from that script. And then once we've done that, we can basically just set up our parameters to read that script of the values and change our parameters accordingly. Again, like all my scripts that I've created on this channel, if you go to my website, I'll have a link in the description. You can just copy and paste this if that helps you, get started. You're more than welcome to. Yeah, so that's that really. So now we've done all that, let's have a listen to how this sounds in game. So I've got everything on. Let's jump straight into it. There we go. So let's start moving. Oh, hold on. Let's move that out of the way so we can see our values. There we go. So it came out quite well. And like I said earlier, this is obviously a very basic way of doing this. You can dive into a lot more audio files to give it more detail. You can add extra audio files like skidding and tires, moving on their own and stuff like that. You can obviously automate them in different ways. But hopefully this does help some of you out. At least get a start on how you can go about adding these kind of audio engines, I keep calling them audio engines, vehicle engines. How you can add their sounds to them. Yeah, and there's a lot more stuff you can go into. But hopefully this helps. Like I said earlier, you can check out if you need the script, if you just want to copy and paste that into your project and get started, you can do that on my website. That'll be linked in the description. Um, Again, highly check them out. I recommend you check out the FMOD channel where they've done their own vehicle stuff. I think there's actually a video of how they show how you can record if you can drive, you've got a car at home, or you have access to a vehicle. You can actually how they record the engine sounds of a car, and that's really interesting how they go about doing that, because they actually I haven't seen the video in a while. I think they use I think they just literally just stick mics under the hood, and as they drive, they've got to drive at certain speeds to get certain tones and the sounds of the engine. It's really cool, so definitely worth just checking out the channel in general. Yeah, and I think that's all there is to it. So thank you very much for all the support, by the way. We've had a lot more people commenting on the videos, and you guys seem to be enjoying it. So hopefully now I can keep them coming. Let me know what you thought of this, and if there's any other stuff you want me to cover. And again, thanks to Valor for the suggestion. So, I've been Henry Scott. Thank you very much for watching.